Okay, once again, our objective for today, I can solve and graph quadratic equations. And yesterday we already started with functions, remember that? And today is very similar, so if you want to create your own Fair model, that's fine. If you don't, that's fine. I'm just going to explain the differences from yesterday to today. A quadratic equation, now look at the definition, is a two-variable equation where the highest degree is 2. Yesterday, for functions, it was a y-form equation and highest degree 2. Very similar, right? Okay, examples. X squared plus 3x plus 2 equals y. X squared minus 9 equals y. Y equals 3x squared minus 11x plus 6. What do you notice on all these? They're two variables. They're solved for y, and the highest degree is what? 2. And let me show you some non-examples. Look at the non-examples. Why would these not be quadratic equations? Tell your neighbor, please. Let's see. How about these two right here? Why are these not quadratic equations? Oliver.
They're not two variable equations.
They're not equations or two variable equations, okay? How about this one?
The greatest degree is not a 2.
The greatest degree is not a 2. So therefore they need to be two variable equations, highest degree 2. Very similar, right, to the functions? Alright? Everybody done? Okay, I'll give you 20 seconds to copy that if you're copying. Go. Copy these steps, please. Only 7.
7 is really like 13.
Right. So in reality, they're like 13, 14. So here we go. Step 1, solve for y. Step 2, substitute 0 for y. Step 3, factor the trinomial. And this is what I mean. In this step 3, how many steps were there? About 5, right? Or 4, something like that. Set each factor equal to 0. Solve for the variable. There's like 2-3 steps, right? And for graphing, also like 2 or 3 steps. So I'm trying to crunch it as much as I can, so I left it only to 7 steps. So copy that, please. The last one is check. I'll give you guys 30 seconds. With that said, copy this example down, please. Now that we have all our 7 steps memorized, yay! Example 1. It says, solve the quadratic equation by factoring and check your answer. X squared plus 8 equals y plus 6x. No, just copy the black text. Solve the quadratic equation by factoring and check your answer. X squared plus 8 equals y plus 6x. So, step 1 says solve for y. So I'm going to draw out my line down the equal sign. And on what side is y? On the right side, so I need to leave y by itself. So what would I do from there? Minus 6x to each side. Minus 6x minus 6x. Now, at this point, look up please. When you rewrite these terms, I want them in standard form, which means from highest degree to lowest degree. So what is the highest degree? X squared minus 6x plus 8 equal to y. So step 1 is done. We solved for y. Step 2, we need to substitute 0 for y. So instead of y, what do I write? 0. And bring everything else down. The equal sign, the x squared minus 6x plus 8. Very simple so far? Yeah, right? Okay. Step 3, Noemi, what does it say? So, if I was to cover this, look up, do we know how to factor this? Yeah, so basically, but now that we have equations, I'm going to uncover it, but our focus would be the trinomial. So, let's check for GCF. Any GCF? No. Open two parentheses. Back to the first term, x and x. Power Rangers, we got 8 and negative 6. So, what factors of 8 add or subtract to give us negative 6? Isaac. Negative 2, negative 4. So therefore x minus 2 x minus 4, and all that equal to 0. Why? Because we are at where? Quadratic equations. We're not at quadratic expressions. Are we there so far? Fairly simple? All right. Step 4. Alyssa. Okay, so at this point I do want you to pay attention. Pens down, pencils down. Let me explain the next step before we do the next step. Here it goes. Look up. I'm going to write some stuff on this side that has nothing to do with what we're doing, but it's going to explain the property that we're going to use. Here we go. At the beginning of the year, I introduced a property, and we called it the zero product property. Remember that? And I said any number times 0 is equal to 0. So 2 times 0 is 0, right? How about 0 times 5? 0, and so on and so forth, right? How about A times 0? What is that? What is 0 times B? All right. But what if we end up with this? A times B equal to 0. So now it's a dilemma, right? What could A be? So A could be 0, or B could be 0. Are we there? So let me ask you this. Here we have the same dilemma. We have this times this equal to 0. Do we know which one is 0? No. So therefore, this one could be 0, or this one could be 0. Everybody with me? Do you really understand why I wrote that? Because we're multiplying, and according to the property, one of these has to be 0, yes? That's why I wrote x minus 2 equal to 0, or x minus 4 equal to 0. What was the next step? It said, set each factor equal to 0. Did we do that? Yeah, copy that, please. You don't have to copy this. This was just to elaborate so that you remember the property. Okay? All right, let's move on. Step 5, it says solve for the variable. So what do I do here? Add 2, x equals 2. How about here? Plus 4, x equals 4, and we're done. These are my solutions, also known as X-Intercepts. And at the high school, they're going to start calling them zeros when you get to Algebra 2. But I'm going to label all terms so that you get used to all the names for these. Once again, what are they? They're my solutions. Well, in itself, what are they? They're X-intercepts, also known as what? Zeros. Everybody understand? So therefore, when I ask you to solve a quadratic equation, at the end you need to box this, and that's what I need from you. Are we there? Step 6 says graph. All right, I'm going to create my little coordinate plane over here on the side. All right. So far, so good? So now check this out. In the warm-up, I gave you an equation for you guys to find the slope and the y-intercept. Is that correct? Yes. But with quadratic equations, what did we find out yesterday in the roller coaster? That there's no slope, that they're actually curves, right? Mm-hmm. So therefore, some of these equations do have one part from the original equations that we started with. So watch. What if I gave you the equation y equals negative 6x plus 8? What was my slope? Negative 6 over 1. What would be my y-intercept? 8. Are we there? Well, with quadratic equations, the last part is still the same. Look at it. What would be my y-intercept? Look at it. My y-intercept is 8, the constant. Let me show you again. For those of you that missed it, here it goes. If I gave you this equation, what was my y-intercept? 8. What's so particular about 8? It doesn't have a variable. It's the constant. Is that correct? Look at this equation. What is the constant? 8. That's my y-intercept. So therefore, I need that one to get started with my graph. I plot 8. There it is. Do the same, please. And what else do I need? My X-intercepts. What are my X-intercepts? 2 and 4. So 2 is about right here. I plot my point. 4 is about right here. And now I graph my parabola. I start from left to right. Here it goes. Roller coaster, roller coaster. There you go. There it is. I should play the song, huh? Yeah, one of these days. Alright, so here's the parabola. What parts did we use? We used a constant from the equation. For those of you that need more visuals, make sure you circle this. Draw an arrow so that you know that that goes there. And our X-intercepts, since we already labeled them, I'm pretty sure that's pretty much self-specific, and then you just know that to plot them there. How are we doing? Let me go through the steps again. Step 1, solve for y. Did we do that? Yes. Step 2, substitute 0 for y. Yes. Step 3, factor the trinomial. Yes. Step 4, set each factor equal to 0. Yes. Step 5, solve for the variable. Yes. Step 6, graph using the y-intercept and the x-intercepts. What is our final step? Check. We'll do that right now. The question was, is there a limit for the minimum of the parabola? Oh, you can actually keep going like this. Or, yeah, it's up to you. But what I don't want to see. Oh, I'm fixing it. Alright, there it is. What I don't want to see is this. 2, 4, and then you do this. Is that a parabola? No. The parabolas have to curve. Okay? Alright, so now that we have that, let's check. Check. Let's write the standard form equation, which is x squared minus 6x plus 8 equals y. So what was our solution, Marissa?
X equals 2.
Okay, which is this one, and 4. So to check if these are correct, I'm going to first start with this one. What is my coordinate for that one? 2, 0. I'm going to substitute these values in here to see if it's true. So this is 2 squared minus 6 times 2 plus 8. And instead of y, what is the value of y? 0. So let's see. 2 squared is 4. Negative 6 times 2, that's negative 12 plus 8 equals 0. Combine like terms. Positive 4 and positive 8, that's positive 12 minus 12, that's 0 equals 0. Boom. What do you think would happen if I substitute the next two values? It would be the same thing, right? And you can do that on your own. Does everybody know how to check? Alright. So, that was only one problem. Yay! So let's see. Step 1, solve for y. Yes? Step 2, substitute 0 for y. Step 3, factor the trinomial. Step 4, set each factor equal to 0. Step 5, solve. Step 6, graph using the y-intercept, the x-intercepts. Step 7, check. We got it? Okay, let's do another one. Here goes the next one. Example 2. Don't copy the verbatim, just write example 2. Here's our equation, y minus 7x equals x squared plus 10. See if you can do this one by yourself. I'm going to give you a head start and then we'll go over it step by step. Copy that. Example 2, y minus 7x equals x squared plus 10. Go. Okay, let's get started. Help me with the first step, please. Tori? Plus 7x plus 7x. We end up with y equals x squared plus 7x plus 10. Thank you. Pass it to someone. Christian, next step.
And then you factor.
Close.
Oh. Oh, you replace the y with 0.
Replace y with 0. Substitute 0 for y. Thank you. Pass it to someone. Danielle.
And then you factor out.
Factor the trinomial. Therefore, this is X and X, Power Ranger, 10, 7. What are my factors there, Danielle, that are 5 and 2? So this is X plus 5, X plus 2, and all that equal to 0. Pass it to someone, please. Lauren B.
You write that either of them is equal 0.
Write each factor equal to 0, X plus 5 equal to 0, X plus 2 equal to 0. Then what do I do from there, Lauren?
You solve for the variable.
Solve for the variable, so what do I do?
Minus 5.
Minus 5 minus 5.
So X equals -5.
X equals -5.
Minus
2
2.
minus 2. X equals -2. Hands have you got for your roots? I'm sorry, your X-intercepts, -5 and -2. That is correct. So these are my solutions. X-intercepts. Zeros. Yes.
For, you know how like on the last problem, the y or the 0 was on the right side?
Yeah.
Like, would it be so wrong if you put like 0 equals 10 plus 7x plus x squared? Because if you look at the other problem, it's just saying that like
It's the same except for the equal sign, and that is on the other side. You see what I'm saying? Yeah. All right, let's graph. What's my y-intercept, everyone? 10. That goes right here. What are my x-intercepts? -5, -2. Therefore, my parabola should look something like this. Hands, have you got that? Okay. And if we were to check, once again, you get one of these. This is -5, 0, -2, 0. Substitute those into the original, and that's how you check. Now, we're there up to right there, okay, right? Now check this out. However, for the home plate, I put a couple of dilemmas in there, such as this. Look up, please. Pens down, look up. I'm going to give you something that looks like this. Tell your neighbor what you would do next. So basically it's already done, right? So the next step would be x plus 5 equal to 0, x plus 2 equal to 0. You solve, hold on. Then this would be x equals -5, x equals -2. But watch, look up. Here's a dilemma. Here we go. This is -5. This is -2. And let me say, multiply these together to get your y-intercept, or the shortcut. What is the last step every time that we multiply these? The last one times the last one, that gives us what? 5 times 2, that's, and that would be our y-intercept. Alright, so, our home plate for tonight is on page 577, numbers 11 to 21. Have a good one, guys. Enjoy your home play. See you guys tamales.